What's going on, everyone? This is Gaurav and welcome to my learning channel. So in today's video, we're going to learn about Monte Carlo simulation. First of all, we'll take a little bit of a history lesson and then followed by doing one Monte Carlo simulation in an Excel sheet. So without any further delay, let's get started. When you think of Monte Carlo, what's the first thing that comes to your mind? Is it something to do with the beach, which is somewhere out there in Europe? Or maybe it has something to do with a casino. Maybe it is in a Europe or some other place in the world. Or maybe it is a complicated formula, and which is something that we're going to learn today. Now, what if I tell you that it is actually a combination of all three? So with that, let's take a quick history lesson of Monte Carlo simulation. Monte Carlo simulation was named after Monte Carlo Casino in Monaco. This was developed by Stanislav Ulam and John von Neumann. I hope I'm pronouncing their name correct. And this was developed in 1940s during their work on Manhattan Project. Now, just in case you don't know what Manhattan Project is, you should definitely look it up. And this method actually relies on the random sampling and probability to solve some of the problem. Now, you don't have to worry too much about this one right now because we will actually do one simulation today. But this is sort of something similar that you would do in a casino as well. And so exactly what it is. So let's try to understand Monte Carlo simulation with a simple example. Let's say that you are a shop owner and the only thing that you sell is corn. So the way your business work is that you buy corn and then you sell it. So you are somewhat of a middleman, and your profit is fairly thin. So for a particular day, if you don't make any profit, then you will have to borrow some money. This is just to keep your lights on and also to buy some inventory for the next day. Now, if you're a shop owner, then you would definitely be interested to know that for how many days would I be in that type of situation where I'll have to borrow the money, because borrowing money is an exercise in itself. It's going to take some time and resources, and you definitely want to be prepared for that. This is where Monte Carlo simulation comes into picture. So with that, let's quickly go to an Excel sheet, and that's where we will first of all try to do a Monte Carlo simulation for this particular scenario. So you'll see that you can do something similar in Python as well. And Python actually makes it much more easier. There's a simple package and you can pretty much do all of the things that we're going to do today in an Excel sheet with a simple one line of code. However, in order to better understand Monte Carlo simulation, it's probably better to do it once in an Excel sheet so that you will know everything that happens in the background. So I prepared this Excel sheet and I have added a little bit of a data point already so that we can save some time. But if you think about it, in order to understand how many days you are going to be making profit, first of all, you will have to understand the demand, which is how many bushels of corn you will have to sell every day. And let's say that you have a demand curve, and let's assume for this particular conversation, that particular demand curve is a normal distribution. So that normal distribution has a mean of 500 and a standard deviation of 100. Let's say for the sake of this conversation that sale price of each bushel of corn is about $2. And the variable cost, which is amount of money that you would need to buy one bushel of corn, is let's say $1.7. Now, I don't know if these are the actual prices or not. I have just taken this as an assumption. So on top of it, let's just say that you also have a fixed cost of $100. So it doesn't really matter if you make any sale on a day or not. You still have to spend about $100 per day. So if I have to do the Monte Carlo simulation, so first of all, I'll go ahead and generate a particular random number. Let's go ahead and do that. And the way to do this random number generation in Excel sheet is just simply using a function called rand. And there you go. You have a random number somewhere between 0 to 1. Now, if I have to calculate the simulated demand value, given the fact that demand follows a normal distribution, I can simply go ahead and use the function called norm.inv. And then I will need a probability value, which is in some number between 0 and 1. And then also I will need a mean, which is 500. And I will also need a standard deviation. So I'll close this. And there you have it. So for one simulated data point, your demand value is 513.7. So what it means is that if I have to follow some sort of a normal distribution, then one of the data point on that normal distribution will be 513 bushel of requirement for any given day. Now, given the fact that I'll be copying this formula all the way down, I will go ahead and add some dollar values here. So just in case you don't know why I'm adding the dollar values, is because once you drag the formula down, then it will just keep on changing the cells. Now let's calculate the profit. So profit will be this, which is the total simulated demand value multiplied by your variable sale price minus your cost. And then again, on top of it, I will have to subtract your fixed cost. So this comes out to be $106 for this particular one data point. Again, I'll go ahead and do the same thing. I'll add dollar signs to these two data points. Good. Now let's just go ahead and generate a whole bunch of data points. So in order to do that, let's say that I want to generate data points for 866. I just picked a random number 866. Feel free to increase it to 1000, 10,000, and so on. More number that you generate, more accurate the simulation will be. So if I have to copy this formula all the way to 866, all I will do is just go ahead and copy it. I just use a shortcut. It's called Control D. But you can go ahead and just simply copy paste the formula all the way down as well. Now, as you can see that you have the profit for each one of these different demand values. Let me just go ahead and add one more F4 right here. So you can see that you have some profit which is coming for every single day. Now, let's say that if I have to calculate number of days where I am going to make some profit and then number of days where I'm going to incur some cost, then I can go ahead and use a formula called COUNTIF. So the way it works is, let me just maybe go ahead and write it. So COUNTIF, and then I'll have to go ahead and pick a range. This is your entire range. Then put a comma. And my condition is that it should be greater than 0. If it is greater than 0, then I will be making profit. If it is less than 0, which is the formula that you see here, less than equal to 0, so then I'll be making a loss. Now you can see that based on this simulation, there is a 50 number of days out of 866 where I'll be making a loss, and about 816 is where I'll be making some sort of a profit. So if you have to calculate the percentage wise, that comes out to be about 5.8%, which is this divided by this plus this. Now you'll see that if I change any of these parameters such as sales price or variable cost or fixed cost, then these numbers will change. So like, let's go ahead and quickly change your fixed cost to $200. Now you will see that the whole thing has changed. So days with a loss is 822 and days with profit is just 44. So overall 94% of the time, or approximately 95% of the time, you will be making a loss. Now let's just revert that. So how does this help? What does this data tells us? This data tells us that if I know the overall demand curve of a particular market, then I will be able to estimate how many number of days I will have to borrow money from someone. And that's going to be approximately 5.5%. You will see that if you keep on increasing the number of data points on which we are doing the simulation to, let's say 100 or 100,000 or about a million, then this percentage will keep on getting more and more accurate and will keep on converging to a particular point. And for the most part, you'll see this is probably going to be somewhere around 5.5% or maybe 4.5%. So that does give you a pretty good directional idea about how many number of days percentage wise you will have to borrow some money. So we just completed the Monte Carlo simulation, a very simple exercise. And the steps involved were, first of all, we generated some data and we defined the distribution. Right now, for the sake of this conversation, I have assumed that it was a normal distribution, but feel free to use any kind of a distribution that you would like to. Second one is simulate for the random scenarios. And again, as I said, that more number of random scenarios, more robust your simulation is going to be. Right now, we have just taken at some random number of 866 times, but feel free to increase it to 10,000 or 100,000. And then, of course, the last step is to infer the outcome. So it's pretty simple, isn't it? Now, the next question is going to be that where do we use something like a Monte Carlo simulation? First one is a risk management, which is scenario-based analysis. So let's say that if you're working in a bank or if you are working in some other institution where there is an inherent risk, maybe you are a trader and you would like to know for how many number of days your S&P 500 or the stock market overall is going to be above its last 10 days value, or for how many number of days it's going to be below that. In order to do so, a very simplistic simulation could be something based off of your Monte Carlo simulation. Some of the other scenarios could be that if you want to do a premium calculation in insurance, then this could also give you a pretty good directional idea that what should be the right premium calculation if all of the different parameters that impacts the premium is well defined and it follows a particular distribution. And of course, if you sell corn, then also you can go ahead and use something like a Monte Carlo simulations. So it's pretty simple, isn't it? So if you have any question, feel free to drop a comment. And if you like the content, please like and subscribe. Thank you so much.